Hello friends, welcome to my channel. This is Thermodynamics part 7. In this video I will cover gas power cycles. First is Carnot cycle. PV diagram. One, two, three, four. 1 to 2 isothermal process, heat addition, 2 to 3 isentropic process, 3 to 4 isothermal, 4 to 1 isentropic process. Three to four is heat rejection, isothermal heat rejection. Here you have to remember two isothermal process and two isentropic process, constant temperature and constant entropy. In Isro, they won't ask you problems based on air standard cycles, so you just remember the basics based on the graph. And here, efficiency does not depend on the gas. Whatever the fluid you can take, same efficiency it will come. Efficiency independent of working fluid. Here TS diagram also important for Carnot cycle. One to two, 2 to 3, 1, 2, 3, 4. TS diagram, it's 1 to 2 isothermal heat addition, QS is heat supplied, and 3 to 4 it's isothermal heat rejection, QR is heat rejection. Then efficiency work done by heat supplied, T1 minus T2 by T1, or you can write T1 T2, T maximum minus T minimum divided by T maximum. Next is Stirling cycle. Stirling cycle, PV diagram, and here TS diagram. Stirling cycle consists of two constant volume process and two isothermal process or constant temperature process. Here two isothermal process and two constant volume process. 1, 2, 3, 4. One to two isothermal, 3 to 4 also isothermal, 4 to 1 constant volume, 2 to 3 constant volume. Then for TS diagram, constant volume, volume is constant, volume is constant. TS diagram. One to two isothermal, 2 to 3 constant volume, 3 to 4 isothermal, 4 to 1 constant volume. Then here important is 2 constant volume process and 2 constant temperature process, and efficiency of Stirling cycle is less than efficiency of Carnot cycle. But one more thing is important here. Efficiency of regenerative Stirling cycle is equal to efficiency of Carnot cycle. So if regenerative mentioned, then efficiency is same as Carnot cycle. So efficiency of Stirling cycle, regenerative Stirling cycle is equal to same as Carnot efficiency, T max minus T minimum divided by T maximum. Next is Ericsson cycle. It consists of 2 isothermal process and 2 reversible constant pressure process or isobaric process. PV diagram I will draw, and after that TS diagram. No application in IC engine. Only some theory, this is important. Problem they won't ask you. Gas turbine application. Ericsson cycle used in gas turbine application. PV diagram I will draw for Ericsson cycle. Pressure versus volume. 2 constant pressure, then 2 isothermal process. 1 to 2 is isothermal process, 2 to 3 constant pressure process, 3 to 4 isothermal process, and 4 to 1 constant pressure process. For TS diagram, one to 2 isothermal process, 2 to 3 constant pressure process, 3 to 4 isothermal, 4 to 1 constant pressure process. Here efficiency of Ericsson cycle is less than efficiency of Carnot cycle, but if you will do regeneration, then efficiency of regenerative Ericsson cycle is equal to efficiency of Carnot cycle. So important thing is here, efficiency of regenerative Stirling cycle equal to efficiency of regenerative Ericsson cycle is equal to efficiency of Carnot cycle, or we can write T max minus T minimum divided by T maximum. Then air standard Otto cycle. 2 constant volume and 2 isentropic. Constant volume process and 2 isentropic process. PV diagram I will draw. Constant volume heat addition. PV diagram. 1 to 2 isentropic process, 2 to 3 constant volume heat addition, 3 to 4 isentropic process, and 4 to 1 constant volume heat rejection. This is heat supplied, heat rejected. Constant entropy process 3 to 4 and 1 to 2. 2 to 3 and 4 to 1 constant volume process, constant volume heat addition and constant volume heat rejection. For TS diagram, 1 to 2 isentropic process, 2 to 3 constant volume process, and 3 to 4 isentropic process, and 4 to 1 constant volume process. Constant volume heat addition and 4 to 1 constant volume heat rejection. And the Otto cycle efficiency is thermal efficiency 1 minus 1 by RC is compression ratio to the power gamma minus 1. Thermal efficiency increases with increase the value of gamma, and thermal efficiency increases with increase in compression ratio. Actual efficiency lies between 25% to 30% for Otto cycle. Next is diesel cycle. Here one process is constant pressure process. It's constant pressure heat addition, and two processes are isentropic processes, and one process is constant volume process. It's a heat rejection process. PV diagram I will draw. PV, then TS diagram. Here constant pressure heat addition, then isentropic process, then constant volume heat rejection, then isentropic process. 1, 2, 3, 4. PV diagram, then TS diagram. Constant pressure process, then isentropic, here constant volume process. Pressure is constant, here volume is constant. Process 2, 3, constant pressure heat addition, and process 4, 1, heat rejection. Constant volume heat rejection. Here heat supplied, heat rejected. 1, 2, 3, 4. Here compression ratio is V1 by V2, expansion ratio RE is V4 by V3, and cutoff ratio rho is V3 by V2. Compression ratio RC equal to expansion ratio RE into cutoff ratio rho. And thermal efficiency for diesel cycle is 1 minus 1 by RC to the power gamma minus 1 whole into rho to the power gamma minus 1 divided by gamma into rho minus 1. Then dual cycle. PV diagram and TS diagram. 1 to 2 isentropic process, 2 to 3 constant volume process, 3 to 4 constant pressure process, 4 to 5 isentropic process, and 5 to 1 constant volume process. So 2 isentropic, 2 constant volume, and 1 constant pressure process. Heat addition, 3 to 4 heat addition, 5 to 1 heat rejection. Like this here, 1 to 2 isentropic process, 2 to 3 constant volume heat addition, 3 to 4 constant pressure heat addition, then 4 to 5 isentropic process, 5 to 1 constant volume heat rejection. Dual cycle efficiency is not that much important for Isro examination, so I am not mentioning it. Only remember 5 processes are 2 isentropic process and 2 constant volume process and 1 constant pressure process. And heat addition is 1 constant volume heat addition and constant pressure heat addition. Comparison of Otto cycle, diesel cycle and dual cycle, I'll do it in next video. Thank you friends. Thank you for watching my video. Thank you.